As per language specification, if any policy of the language is decided at the compilation time, then we say that the policy is a static policy. On the other hand, if any policy of the language is decided at the runtime when program is running, then the policy is said to be dynamic policy. In order to understand the difference between static and dynamic, let's take a small example. We are declaring a variable x. We're defining a function with the name a. In the function a, there's a definition of the variable with the same name x, and then I'm referring to the variable x in the function a. Followed by this, there is one more function defined. The name of the function is b, and in the function b, I am referring to the variable x. A very small example. Let me now give you the scope rule or the policy. The policy is there are only two scopes, local scope and the global scope. Variable will be searched in the local scope first of all, and if it is not found there, then the global scope will be searched. Let us now consider this reference of the variable x. This reference is there in this local scope, so this will be searched first of all in this local scope. I already have a definition of x existing in this local scope, so this reference of the variable x binds to this definition of the variable x. Let's now consider this reference of the variable x in the function b. It is there in this local scope, so I first of all search this local scope. I do not find any definition of x in this local scope. Now I search the global scope. In the global scope, I find the definition of the variable x over here. So this reference of the variable x in the function b binds to this definition of the variable x, which is globally defined. Now if you look at this policy can be decided by examining the program code, by examining the program structure. If I want to resolve any reference of the variable x, if I want to know to which definition a variable reference binds to, I can determine this by looking at the program code. I can determine this by looking at the program structure. So this policy is static because this can be decided by the compiler at the compilation time. So this policy is a static policy. Let me now give you another policy, and this policy states that for a variable reference, first of all it will be searched in the currently executing function. If it is not found there, then it will be searched in the parent function. If it is still not found there, in this manner it will be going up. So let's consider that main has given call to the function a, and a has given call to the function b. When I refer to the variable x in the function b, it will be searched first of all in the function b. It is not found there. Then I search and look for the variable x in this invocation of the function a. Here it will be found. So that means this reference of the variable x in the function b binds to the variable x which is there in the function a. So that means this policy is dependent upon execution pattern. So if the execution pattern is like this, main has given call to the function b, now I refer to the variable x in the function b, then I will refer to some other definition of the variable x. So this is dependent upon what is the program execution pattern. Since the program execution pattern cannot be determined at the compilation time, so this policy is dynamic policy. Let's take another example of static scoping and dynamic scoping. In this program segment, there are three definitions of the variable p. One definition of variable p is over here, it's a global definition. Second definition of variable p is there in the function f. And the third definition of the variable p is there in the function g. In the function h, we are printing the value of p. Question now is, when we refer to the variable p in the function h, which definition of p is being referred in this reference? Let's first of all consider static scoping. In the static scoping, variable will be first of all searched in the local scope. If it is not found there, then it will be searched in the global scope. When I refer to the variable p in the function h, there is no local definition of p in the function h. So this reference of p binds to the global definition of p. So that means in the function h, this will be printing the global variable p. What is the value of the global variable p? This is being assigned a value of 10 in the function main before the h is executed, or before the h is called. So that means the output of the function h will be, it will print the value of 10 on the screen. Since h is being called twice, one along this particular path, the second along this particular path, so the output of this program, if I consider static scoping, will be 10 and 10. Now let us consider what will be the output of this program if there is a dynamic scoping. In case of dynamic scoping, program execution begins from main. Main assigns a value of 10 to the variable p. When I refer to p in main, it is the global p that we are referring to. So the global p gets the value of 10. Main in turn gives call to the function f. F has got a definition of the variable p. Function f has in turn, and this is being assigned a value of 20. F is giving call to the function h, and in h we are printing the value of p. So when I print the value of p in the function h and I refer to the value of p in the function h, I search for h in the function h that I do not find. Then I search for p in the function which has called h, so I search for p in the function f, so I find it over here. So this value of p is printed, so the output is 20. Then I return from the function h, I return from the function f, I come back to main and I call the function g. G has got a definition of p and it assigns a value of 30 to this. G now gives call to the function h, and in h once again we are printing the value of p. So when I refer to p, I search for p in the function h, I do not find it there. Then I search for p in the calling function. So now h has been called by the function g, and g has got a definition of p. So that means now the value of this p will be printed in the function h, so the output is going to be 30. So if I consider the dynamic scoping, this program segment will produce the output of 20 and 30, and if I consider static scoping, this program segment will produce the output of 10 and 10. Let's look at another example. In this example, we are using nested scoping. If you look at this program, we are defining procedure P1. Within procedure P1, we are defining two more procedures. One is P2 and the second is P3. The point to be noted here is P2 and P3, they are defined inside P1 or they are defined in the scope of the P1. So one scope is nested inside another scope. Let us see what will be the behavior of the program if I consider static scoping and what will be the behavior if I consider the dynamic scoping. In the black color, I'm showing the global scope. Then the scope of the procedure P1 is being shown in the purple color. Within the scope of the procedure P1, we are defining the procedure P2 and P3. So scope of the procedure P2 is shown in the red color and the scope of the procedure P3 is shown in the green color. Let's first of all consider static scoping. In procedure P2, we are referring to the variable x. So in static scoping, what will happen is, when a reference to a variable is made, variable will be first of all searched in the innermost scope. If it is not found, then it will go up and search for the variable in the next scope. If it is not found, then it will further go up and search for the variable in the next scope. So in this case, if I refer to a variable in P2, if it is not found in P2, it enclosing spaces the scope of P1, there it will be searched. If it is not found there, then the enclosing scope is the global scope, there it will be searched. So when I refer to the variable x, will search x in the procedure P2. Since it is not there, so now we search x in the procedure P1 and there it is defined. So this reference of x binds to this definition of x. This is the behavior of the program in case of static scoping. Let us see what will happen in case of the dynamic scoping. For the time being, let us consider that execution pattern is like this. Main has given call to procedure P1. P1 has got a definition of the variable x. P1 has given call to procedure P3. P3 has got a definition of x, and P3 has given call to the procedure P2. In P2 we are referring to the variable x. Now in P2, when I refer to the variable x, I look for the definition of x in P2. Variable x will not be found here. Then the function which has given call to P2 is P3. I search for x in this invocation of P3. X is found over here. So x of P2 binds to x of P3. Let us consider another execution pattern. Main has, for example, given call to P1. P1 has given call to P2. P1 has got x defined. So when I refer to P2, when I refer to x in P2, I search for x in P2. It will not be found there. Then the function which is given call to P2 is P1. In P1 x is defined. So reference of x in P2 binds to x of P1. So if the execution pattern is this, reference of x in P2 binds to x of P3. If the execution pattern is this, reference of x in P2 binds to x of P1. So this is the behavior of the program in dynamic scoping. In dynamic scoping, it depends upon the execution pattern. Let's take another example of static policy. In this example, binding is taking place statically. There are two classes defined. One class is named as country, and the second class is named as Japan class. Japan class is derived from the country class. If you examine these two classes, both these classes are containing a method with the name language. In the main function, I'm creating a pointer which is pointing to an object of type country, and I'm creating an object which is of type Japan. I'm making this pointer point to Japan object. Let me draw the diagram. I have created an object, and this object is of type Japan, and this object is being pointed by a pointer. The name of the pointer is CT, and this pointer is of type country. I'm giving call to method language in the last statement. Now, since language is being called with respect to the pointer CT, and CT is of type country, so this invocation will bind to this definition of the language. Now, if you examine this binding can take place statically at the compilation time. So at the compilation time, it can be decided that to which definition this will bind to. So this binding is a static binding. In the previous slide, we'll take an example of a static binding. Now we'll take example of the dynamic binding. The example is same as that of the previous slide with minor difference. And what is the difference? This function has been made as virtual function. Since it is virtual in the base class, so this makes it virtual in the derived classes too. The main function remains to be same. We have a pointer which is pointing to an object of type country. We have created an object which is of type Japan, and this pointer which is of type country is pointing to an object of type Japan. And then I'm giving call to language method. Now since the language is defined to be virtual, so the binding will be dynamic binding. So at the runtime, which language is going to be called will be decided. At runtime, it will be checked what is the type of object. If the type of the object is country, language of the country will be called. If the type of the object is Japan, language of the Japan will be called. So this binding is dynamic binding. Now here is another interesting example. You know that private member of a class cannot be accessed outside the class. But using the dynamic binding, it may be possible. We have made a small modification in the previous example that we had taken, and the modification that we had made is this method has been made private in the Japan class, which is the derived class. Rest of the thing is same as before. Now whether the member is private member or public member or protected member, this is checked at the compilation time. It is checked statically. At runtime, when the program is running, this checking does not take place. So when I give call to this function, and this function is a virtual function, so this will be resolved at runtime, but at runtime I do not check whether this method is private method or public or protected method. So that means even though this method is being called with respect to the object Japan, and in the Japan class this method is defined to be private, but I'll be able to call this method using the dynamic binding. Let me now summarize the discussion that we had. One situation which we had considered was there is a reference to the variable x, and this reference to the variable x is being resolved statically at the compilation time. The second condition that we had considered was there is a reference to the variable x, and this reference to the variable is being resolved dynamically at the runtime. So at the runtime, I'll be looking at the execution pattern of the program. So for example, main has given call to the procedure P1, P1 has given call to the procedure P2, and in P2 there is a reference to the variable X. So I will look for X in the P2 at runtime. If it is not found, I'll look for X in P2, P1, and if it is not found, I'll look for X in P1 and so on. So in this case, when the variable reference is made at runtime, there is checking involved. So you have to do a lot of work as to where that variable is existing. So that means in case of dynamic policy, you will pay the price in terms of efficiency. So your program will not be all that efficient. On the other hand, in static policy, no such checking take place at the runtime, so your program runs much more efficiently. Similarly, in case of object method call, if I have a pointer and with respect to this pointer I am giving call to a method, the name of the method is language, and if this call can be resolved statically, then the program will be efficient. On the other hand, in case of dynamic binding, at the runtime, I will check to which type of object CT is pointing to, and if it is pointing to one type of object, I will give one call to language method, and if it is of type another object, I'll give call to another language method. So here also, in case of the dynamic binding, at the runtime there is work to be done. There is effort required for checking what type of object it is. So here also for the dynamic policy, we'll pay the price for efficiency, and if it is static, the program will run much more efficiently.